Okay, Chapter 2, Problem 46. We have the swimmer that takes off from the diving board going 4 meters per second straight up, and her takeoff point is 1.8 meters above the pool. Part A is how long are her feet in the air, right? Part A. How long are her feet in the air? So let's look at her position. Y equals 1 half AT squared plus V naught T plus Y naught. Now we know a lot about this equation. I mean, we know a lot of things in here. We know that she starts off at 1.80 meters, right? We know that her initial velocity is 4.00, equal sign in there, 4.00 meters per second. We know that the acceleration of gravity equals minus 9.80 meters per second squared, right? And we know her final position when she hits the water, because we've chosen that as our reference point. Her final position when she hits the water is in fact 0, right? So if we stick all that in, what we've got is 0 equals minus 4.9 meters per second squared time squared plus 4.0 meters per second. Let me put a space in there. Times time plus 1.8 meters. Now, this is nothing other than a quadratic formula, right? We've got 0 equals a times t squared plus b times t plus c, right? And so let's go over to A, B, C. All right, A is minus 4.9, C is 4.0, and B is 4.0, and C is 1.8. The quadratic formula, all right? Quadratic formula applies to equations like AT squared plus BT plus C, and for those, T equals, all right, minus B plus or minus square root b squared minus 4ac divided by 2a. All right? So there are two roots here. And so if we look at this, we'll set it up. All right? Our first root is minus b plus the square root of b squared minus 4 times a times c divided by 2 times, divided by 2 divided by a. All right, so we get one time that is minus 0.32 seconds. All right, and the other one is minus b minus the square root of b squared minus 4 times a times c, right, divided by 2 divided by a. All right, so 1.14 seconds. All right, so time is 1.14 seconds. What does the other solution to this mean? The minus 0.32 seconds. Well, that means if you ran this problem backwards in time, that's when she would have come up off the water. But that's not a physical answer, right? Because the problem starts at t equals 0. All right, so how long are her feet in the air? 1.14 seconds. What is her highest point above the board? So to find our highest point above the board, we need to find when she gets there, right? So part B, what is our highest point above the board? Well, her velocity is acceleration times time plus initial velocity. All right? What's one of the things we know about her velocity when she gets to the top? When she gets to the top, her velocity is 0. All right? So what we're doing first is finding when does she get to the top, right? So 0 equals minus 9.8 meters per second squared times time she gets to the top, right? Plus, she starts off with 4.0 meters per second. So the time she gets to the top is 4 divided by minus 9.8, no, divided by 9.8, sorry. Seconds is, all right, when she gets to the top is 4 divided by 9.8 is 0.408 seconds. All right, 0.408 seconds. Okay, so just to show you another way to get to that answer real quick, if we go back to Excel and you think about the problem in its symmetric form, we can go backwards in time. At minus 0.322, she was on the water. She goes up, she hits her peak, she heads back down, and hits the water again at 1.1388. All right, so if we took the average of those two times, that would give us when she was right in the middle, which is when she's at the top. And the average of those two times is 0.408. All right, so that would be another way to get to the time when she hits the top. Now that we know when she reached the top, right, what is her highest point above the board? So now we're back to y equals 1/2 a t top squared plus v naught t top plus y naught, right? So this is minus 4.9 meters per second squared times 0.408 seconds squared plus 4.0 meters per second times 0.408 seconds plus 1.80 meters. Okay, so minus 4.9 times the time squared plus 4 times time plus the 1.8 meters, and we get 2.61 meters, or 2.62 meters. 2.62 meters above the pool, right? 2.62 meters above the pool, and so above the board, y equals 2.62 meters minus 1.80 meters, right, equals 0.82 meters above the board. All right. Highest point above the board, 0.82 meters. What is our velocity when her feet hit the water? When her feet hit the water. So part C. What is her velocity when her feet hit the water? Well, velocity is AT, right? AT plus V naught. And we have velocity equals minus 9.8 meters per second squared times, what's our total time? 1.14 seconds, right? 1.14 seconds. 1.14 seconds plus her initial velocity of 4.0 meters per second. Okay. So equals minus 9.8 times 1.414 plus 4. So her final velocity is minus 7.17 meters per second. Minus 7.17 meters per second. Because she's heading downward at that point, her velocity is negative, and that's the end of the problem.